Good morning, my name is Jim Hansen. I'm a project engineer at EWI on the arc welding and directed energy deposition team. Some of the industries we really like to work with are shipbuilding, our heavy manufacturers, whether that be through tractor trailers, earth movers. We're also really seeing an interest in offshore wind, and that's something we're certainly looking to get into. It's a big push for the clean energy, and we'd really like to be making those in America. We have a pretty wide range of submerged arc welding capabilities. We can run from single wire all the way up to a 4-wire system we have sitting behind me. We've run tandem, twin wire, as well as the new ESAB ICE system, which we started using here in the last couple of months. This process gives us the ability to run up to 100 pounds an hour. With a lot of our submerged arc welding processes, heat input and deposition rate are the two big kind of competing factors. With a lot of these specialty steels, we need to be very conscious of our heat input for metallurgical property concerns. But with every business, they're trying to maximize their deposition rate in their pounds per hour. Some recent technologies that we've been using are some of the multiple wire processes where we are able to melt 2 wires with 1 arc. In the case of the ICE system, we are able to run a cold wire between a twin wire process. So with that, we're able to run 3 wires off of 1 power supply, which allows us to really kind of cut that heat input down while still increasing that deposition rate, and really proving a business case when we move to some of these more advanced submerged arc technologies that may require a little bit more of a upfront investment on the process. Another thing that we're really excited about with some of these multi-wire processes is the ability to mix wire compositions as we are welding. It gives us a possibility to look at different wire formulations without really formulating those wires by feeding 2 separate wires into the arc. Different steels are being formulated. We need to have the wires and the joining technology to be able to work with these higher strength, lower weight alloys. And I think that welding them in thick sections, we can really accomplish that, potentially through different wire formulations, and stuff where we can have multiple wires across 1 arc really gives us that ability. Kind of gets us close to the space of functionally gradient materials. This is something that certainly has not really been looked at in the submerged arc space. But with multiple wires, we could gradually change our weld deposit chemistry by adjusting the feed rate and the type of welding wires that we're using. EWI does a really good job of kind of proving ground for either technologies or alloys. We are able to lower that cost of entry for a company. Instead of buying a new robotic system and hoping that it works, we are able to prove out whether that be the process, the alloy in our lab, and can give our customers a reasonable sense that the investment that they're going to make will be successful in their shop, in their lab, and in their company.